Hey everybody, we'll get started here in just a minute. It looks like people are still flowing in. We'll get started here at about 3 after. Let's just wait 2 more minutes. For people that are coming in now, are you already using infrastructure as code in your organizations, or is it something that you are looking to start doing? And if you are, what tools are you using? Are you using OpenTofu, Terraform? Feel free to share in the comment section. Okay. Just going to wait here just another minute or two, and then we'll go ahead and get started. Are there any topics that people are particularly interested in with generating infrastructure as code, or any topics on OpenTofu or Terraform that you want me to try to make sure that we include in the presentation today? Just checking comments across all the places we're streaming. Okay. Okie doke. Well, we'll go ahead and get started here. And okie doke. Everyone, thanks for coming today. My name is Corey. I'll be the host. I'm the CEO and co-founder of MassDriver. MassDriver is a visual internal development platform that enables teams to deploy production-ready cloud infrastructure and applications in minutes. Operations teams just write code in Terraform, OpenTofu, Pulumi, Helm, etc. Whatever ISC tools you know, they publish it into our registry, and then their engineers are able to self-serve by diagramming infrastructure. Won't see much of MassDriver today. We're going to pretty much be in the console all day generating code. But if there are any questions during the webinar, a few of my coworkers are in the chat answering questions, and we'll also do some Q&A at the end. So what we're going to do today is just a quick little presentation, and then we'll hop into some hands-on. We'll talk a little bit about what infrastructure as code is. We'll do a whirlwind tour of something we call use case-oriented module design. I'll talk a little bit about why I think you should avoid using the public registry modules and write or generate your own. And then we'll go through generating ISC with Terraformer with some Q&A at the end. So let me just make sure that all of my screen share stuff is going good. Let me maximize that. Does everything look good for everybody? Sharing my screen. Okie doke. Cool. So what is infrastructure as code? So let's start with a simple definition. It's managing and provisioning infrastructure through code in a declarative manner. Focuses on the what of the cloud, not how to get it. IC is integral in the modern cloud ecosystem. It helps make fast provisioning, consistent provisioning. It helps you get to scalable infrastructure management. And the best way to think of it is fancy JSON with a little bit of logic, right? At the end of the day, we're just making HTTP calls to somebody else's cloud API. And one of the most important parts of IAC is automation. Like, that's the biggest benefit you get from it on paper. I think in reality, there are 3 other benefits that are pretty big to teams. One is reproducibility parity. Once you design one of these modules and it's very use case oriented, what it allows you to do is quickly spin up new environments, whether that's a disaster recovery environment, a fully isolated environment in another region, maybe you need GDPR compliance with like hard isolation, or maybe you're just spinning up test environments or preview environments. So that reproducibility parity, I think, is really, really key to having essentially an agile cloud experience. The other really big thing is auditability. It's very hard to audit what happens through the AWS or GCP console when somebody clicks around managing stuff. But if you have a paper trail of all the changes to the cloud, it becomes very easy to hop into Git or hop into a tool like MassDriver and look at what's changed about your infrastructure recently if you're in the middle of an outage. And then finally, collaboration. It's impossible to collaborate over the AWS console. And what's really nice about using infrastructure as code is we can open PRs, we can see the changes that our teams are making, and actually remove some of that wall between dev and ops. Developers are able to open PRs for changes they want to implement. Ops can kind of give them directions on fine-tuning configurations and making sure things are production worthy. So there's just a little overview of infrastructure as code. What I want to talk about now is use case specific modules. So the module we're going to work with today is a very use case specific module. It is AWS Aurora Postgres. It's not an AWS RDS module. It's not an Aurora module. It's very specifically Postgres, and it has a lot of our high availability configurations hard coded in. And the purpose of this is, when you look at the Terraform registry, you'll see a lot of modules like S3 bucket. It's like, well, that's great. I need an S3 bucket, but do I need a module around the Terraform provider for making an S3 bucket, right? What's more beneficial, in our opinion, is use case specific modules, like a logging bucket, where I can hide a lot of the configuration and only expose what's pertinent to logging, or maybe an ETL bucket, maybe a gold stage bucket for stuff going through our ETL pipeline, or a landing zone bucket where I fine tune like SFTP configuration. So this is the direction we tend to lean. What's really nice about them is you get minimal interfaces. You don't have a ton of variables exposed on the modules. It reduces complexity, makes them a little easier to maintain. You lean into a lot of hard-coded values. And this is great because you're actually hard-coding your opinions about how things work instead of exposing variables for every single thing under the sun. Gives you the ability to build a lot of guardrails into your modules so you can kind of package up your operational expertise and feel confident that your developers can use these modules without having to read a white paper on high availability. And then we also will talk a bit about presets, or we use this concept of presets, which is effectively modes of running the module, right? So if you're thinking about something like, let's say Postgres, I would expose two modes. I would expose something like a production mode and a development mode, and I would hide all my operational concerns behind that. So now my developers can say, hey, I want a production version of Postgres or a development version of Postgres version 16, and they don't have to think through all of our high availability concerns. So this is how we design modules. When we look at the Terraform module today, you're going to see it's very use case oriented. If you're interested in use case oriented design for Terraform modules, we're also hosting a webinar on this, I believe the last week of May. If one of my teammates could share that link, I definitely recommend signing up for that if you're just getting into infrastructure as code, or if you've been doing it for years and want what I would consider a better way. So one last thing before we hop into the hands-on, I want to talk about the problem with the registry modules. So there are a lot of modules on the Terraform registry and OpenTofu registry. And I would say that most of these have what I call abstraction bloat. They create a layer of indirection without adding any value whatsoever. Low value code, high cognitive load. This is just a snippet from the AWS, the canonical AWS VPC module. What we see here is a couple of very common smells when I see Terraform code. Direct attribute mapping. So I've got some variables over here on the right that I'm mapping to just the attribute of the exact same name. And when you look through this module, what's really interesting is you also have this idea of attribute bloat. So if you look at a VPC in AWS, it has 27 attributes that you can set. When you look at this module, it has 220. That's a lot of attributes, right? And it's a lot of overhead to think about. And that's not even counting the number of outputs that this thing has. And so what you see here is this module has about 113 contributors. This is 113 people, probably at different companies, saying this is our opinion of how you should configure your cloud infrastructure. A bunch of opinions on how to configure one thing turns into this amalgamation of attributes just being mapped all over the place. Like there's no real value in here. You don't see any expertise. And so this is one of the things that I try to avoid personally when I'm writing Terraform is using the public registry modules. I'll reference them. What I found they're good for is getting an idea of all the different resources that might fit into a module. And then I'll pretty much start there. And then I'll hard code a lot of these values that I know aren't important for my team or aren't important for my use case and expose a minimal set of variables instead. So comparing this to mass drivers VPC internally, we only expose 6 attributes. And we code all of our security, all of our subnet math into the module, so you don't have to think about a lot of things like IPv6 CIDR ranges, net masks, etc. So that's just a brief introduction to IAC, some of our guiding principles around IAC development. And so with that, I'm going to go ahead and stop sharing this tab. We'll hop over to VS Code, and we're going to generate some IAC. Before I do that, I do want to pause really quick and just take a gander at the chat, see if there's any questions. Okie dokie, it does not look so. Okay, so let's go ahead and share a screen. So normally I would be fraught doing a live demo of some code stuff, but today I'm not. And the reason why is the entire process of generating IAC is bumpy. So you are not going to find a silver bullet solution here for managing infrastructure as code. What you're going to find is these are tools that are going to get you 60 to 80% of the way there. And there's going to be a lot of work left for you to do to kind of get them over the line. There's a lot of tools in this space. Today, we're going to be using something called Terraformer by the Waze team at Google. It's by far the best, but even looking at its commit history, it hasn't had a major release in almost a year. Right. And so this is what a lot of this space looks like. People will kind of build these tools and then it's kind of like abandonware almost. And even looking at Terraformer, you'll see that it's going to generate the wrong resources sometimes. So you do have to have an understanding of the cloud and the resources that you're managing to make sure you're getting the right configurations. And then it will also just create completely invalid syntax and configurations sometimes. So you do have to do a lot of work. It does not generate variables for you, so you still have to design your interfaces. It does create state files, which is nice. But if you're going to be invoking this module multiple times, it's up to you to kind of create workspaces and back those state files out into individual workspaces for something like staging versus prod. So we won't get into all of the state file and workspace management today. We're going to kind of look through the different ways of generating IAC with Terraformer, because there's about 4 or 5 different approaches. And I'll talk about some of the downsides of each, and then I'll show you my approach for massively just generating tons of IAC quickly using Terraformer, and also using tools like mods, which is a CLI tool that sits in front of tools like OpenAI, CodeLlama, etc., to help you use AI to fix some of the code. Now, you might be thinking, hey, why not use AI to just generate the infrastructure as code? This is something I've experimented with days and days and days at length, and it's just not there yet. Even identifying the resources that should be in a module is not something that I've seen one of these tools do very well. So Terraform is probably the best we've got right now. There are a few other tools out there. There's AZ to Terraform for Azure. There's Terracognita, which is by the Cycloid team. Has more recent updates, but has less resources that are supported. This, by far, Terraformer has the most amount of clouds supported, but again, it does not necessarily support every single resource. So with that, let's get started. So if one of my teammates will share the GitHub repo, there is a follow along that you can do. You can also do this later if you don't want to follow along in real time. I will say that running the initial module to get everything set up can take about 15 minutes. So if you are thinking about following along, you'll probably need a time machine. But what you'll see is the first thing that we actually do is I built a Terraform module to set up some resources that we'll try to generate some IAC from. So what this does is 2 things. A, it gives you a really nice way of starting this tutorial and then tearing down these resources later, because you can actually just go back to this main module that we start with and do a tofu down or tofu destroy or a Terraform destroy. It also gives us the ability to take what I would consider good IAC and the IAC that's generated and see what kind of differences are being created here. So I'm just going to switch into this module real quick. This is a module that makes an AWS Aurora Postgres instance in our very use case oriented design that we do. You can see over here, this is just the cluster for that. So you can see we hard code some of these values. And we codify a lot of our internal constraints. And so there's a ton of code in here. bunch of different resources. But so if you're following along, you'll need to apply this, running something like Terraform apply or Tofu apply to stand it up. I've already done that, so I'm just going to go ahead and do a Tofu show to show the infrastructure that I built earlier today, that we're going to try to reverse Terraform and generate Terraform from this. So one of the things I want to do first is just show what was actually created by this. So what I'm going to do is, where am I at? Cat resources. So you can see here are all of the individual resources that I made with this module. So this is just a little JQ command I ran to kind of get all my IDs and the types together. So this is something you won't do when you're trying to generate IAC because you don't have IAC to start with, but this is just something I want to use to kind of point out how this generation is going to work. So in my module, I used a bunch of random provider resources. These are essentially resources that just do some sort of code execution, do things like generating passwords, generating random IDs, generating random names. Your IAC or Terraformer reverse generating Terraform code will never get these random fields because they're not stored in AWS. This is some stuff that's just stored in my state file. So we will not see these showing up in any of these strategies that we're going to apply. You also see that I've got security group rules, security groups, RDS cluster instance, subnet group, and then my actual cluster. So just kind of a little foot gun that I've set up here. AWS RDS cluster instance is actually not supported by Terraformer, but what you'll see is when we run Terraformer, it will generate something. So this gets very, very interesting later on. So this is one of the things you have to watch out for. And Terraform does have a big list of all the resources that are supported. If you go into their repo and you click on docs and then go into AWS, for each of the clouds, they have a list of their supported resources. But this is not one of them, and it will still generate code for it, which is interesting. The other thing that we'll see is throughout all of these strategies, none of them will pick up the individual AWS security group rule that we have in our actual module. Let me go ahead and just search for this really quick. You can see here the way that we design our security groups and security group rules is we split them up. It will not do this when it generates the code. It will actually use a ingress block and it will put all the rules inside the main security group. So just something to know, there's a couple of resources that behave this way where if you might expect them to be split up into individual resources, it'll actually use Terraform's block logic to put it into a single resource. And if you look through the docs for Terraform, there are ways to turn that functionality off. But with that, let's go ahead and get into generating some infrastructure as code. And so what I'm going to do is I'm going to show everybody the foot gun that the docs start you with. So I'm going to go ahead and change directories into this repo called everything. And so one of the first things you have to do when using Terraformer is you have to at least have a providers file that has what cloud you're going to be generating IAC for. And then the other thing to know, we're going to be using OpenTofu today, mainly because I'm wearing the shirt. We're also one of the companies behind OpenTofu, and I think it's a really important open source initiative. You can use Terraform or OpenTofu for this demo. You will see me use both, and the reason why is Terraformer only works with Terraform. So Terraform lays down some stuff on your file system for where your providers are actually stored, and Terraformer is looking specifically for those directories. You can just symlink those directories to the OpenTofu ones, and everything will just work, which is kind of funny. But it was cumbersome to do all the symlinking while walking through the demo, so I'm just going to do a Terraform init here. And so what we're going to do is we're going to do the first approach that you see when you look at the docs for Terraformer, and that is to import everything. Now, I would not recommend ever using this approach. It is actually an extremely dangerous thing to do. So when I run this, first off, you see I'm excluding something here. If I don't exclude identity store, Terraformer actually just segfaults and crashes, or sorry, throws a panic and crashes. So I'm excluding those ones here. Not sure why Terraformer is having a problem with that one. But I'm going to run this and then I'm going to immediately cancel it because this actually takes about 2 hours to run on my machine. But what this is going to do is it's going to try to import every single one of the AWS resources in region 2 into a Terraform module. And I'll go ahead and stop that because it's going to take a while. So what I want to point out here is like, this is the way that you see a lot of tutorials online, like showing you how to get started with Terraformer. It's extremely dangerous. A, it takes a long time. B, it is not a best practice whatsoever to put all of your Terraform inside of one module. That is a massive, massive blast radius. And the biggest risk to this is if you accidentally ran Terraform destroy or Tofu destroy, it would actually destroy your entire cloud environment. So I would never do resources all, but you will frequently see that referenced in the documentation. Also bear in mind, if you are using this approach, you can actually exhaust the AWS API. You might not know that that's possible, but they will rate limit you. So you'll need to fine tune your rate limiting a little bit with Terraformer to say how many times you want to retry, etc. So like, why would you ever do every single resource? I can only think of 2 use cases where this might make sense. If you have an extremely minimal cloud presence today, maybe you've only got a couple of lambdas set up with, API gateway. Great. If your entire presence makes sense as a single use case, import everything. But I would expect that to only ever happen with somebody who's very, very early in cloud adoption. The other place that this is actually useful for is if you're a SaaS company and you are trying to make your product where it can be deployed in other people's clouds, and you want to make a Terraform module of just your entire infrastructure setup that they can run, that's actually where this is pretty interesting. You can build an AWS account, set up essentially what like a tenant would look like, run this, it generates all of the IAC, and then you can say, hey, if you want to run my product, here's a single Terraform module to stand the entire thing up. That's about the only use case I can think of this is good for. So let's go ahead and move on. So the other option is doing it by resource types. And this is kind of like the base functionality of how Terraformer works. And so by doing resource type generation, what you're essentially saying is, I want everything in RDS in this Terraform module. Now, you might be hearing that as a cloud engineer and thinking, that's not what I want whatsoever. Yeah, no, I don't think anybody does. And we'll talk about some of the use cases where this might be useful in a second, but let's actually walk through and see what this looks like. So let me just go ahead and remove all the code here. And then I'm going to go ahead and add a provider and then Terraform init. And I'll talk through this while that's running, so it can take a second. So what we're going to see here is we're going to import everything in RDS into a single module. So what that means is if I have a production cluster and a staging cluster, they're both going to be in the same module. That's not great. You don't have parity there. You have everything in one place. It's actually also a little dangerous. If you ran Tofu destroy or Terraform destroy, you can destroy all of your databases in one go. But this is another very common pattern you kind of see in some of the documentation here. So let's go ahead and run this. We'll see what the Terraform looks like. You can see that it's hitting the API a ton of times, and it created 76 resources here. So what I'll go ahead and do is navigate to this. So by resource types, and if we look at RDS cluster, what we'll see is, and by the way, I know that you guys might see our passwords for some of this stuff. I'm okay with that. This is all sandbox stuff. I'm not running it in a real production environment, and all these run on private subnets. So if you see a Postgres password, go ahead and try to use it. So what I want to do, though, is just kind of show what some of the code looks like here. So first, since this ran for all of RDS, you'll see that I've got 3 different RDS clusters in this IAC module, which is not ideal. If I go over to instances, you'll actually see I've got 3 different database instances from 3 different clusters here. You'll see that I've got a ton of different snapshots. So like, even though I don't want my snapshots necessarily being managed in IAC, every single snapshot that was in RDS is now here. So this is a very naive way of going about generating IAC, but I do want to just kind of look through a couple of things here really quick to show you some of the things you need to watch for when using Terraformer. First off, the names are very bad. You can see that this isn't a name that is conducive to parity. It's actually got a lot of the attributes of the actual resource burned right in. You'll also notice that if you use tagging, it will give you the tags and tags all instead of just giving you tags or tags all. So this will actually be a problem later. And you can see that it will do things like generate string versions of Booleans. Now, this is technically fine in Terraform, but it is an eyesore for anybody who appreciates the type system. So yeah, just a couple of things to watch out here when we're generating IAC. So cool. So let's go ahead and just check this out really quick. So if I just grep for the phrase resource, essentially the resource block in Terraform in this directory, you can see that there was 76 resources that were created by this generation. And now if I look at, I'm just going to do a little JQ magic here. I'm going to parse the Terraform state of the Terraform module I used to create this. And I'm going to grep for AWS resources here. And you'll see that there was only 5 resources that we originally created. So that Terraform module that we ran to set up everything only created 5 resources. That's what I'm looking for. So I'm going to get those 5 resources. Now, this is something we can do as a part of this hands-on because we use Terraform to generate the resources. But in the real world, you won't have this magic useful list of IDs. We will get to how I go about this a little closer to the ends of the hands-on. But let's talk about the use cases of where doing a resource or resource-oriented import would be useful. Again, small cloud presence where you have few environments, this might be useful. If you want to back out the configuration of, say, your staging and prod to some workspaces, this might be a good start. You'll still need to do some pretty heavy variable design for your modules. You will need to also do state surgery to pull apart these different clusters that I have here into different workspaces and state files. If you need to just get an understanding of what you have in the cloud, this might be a nice approach. Like if you kind of want to scope down and think, okay, well, what do I have running in RDS? This is a nice way to kind of get all their configurations in one spot, but I wouldn't say it's a great way to manage. It's more of like a discovery mechanism. And then, I don't know that this is a best practice, but I'm sure some team works this way. But if you have operations teams where like a very specific team manages all of that resource, this might be useful. Maybe you have a team that manages compute and they manage all of your Kubernetes clusters. Sure, that might be useful in that scenario. Or you have DBAs and they manage all of your RDS stuff. Sure. It's a good way to get started, but there's still work to do if you go through this route because you still do need to split up each set of resources into its own workspace in Terraform. Okay, and so now I'll go with what is honestly probably the biggest foot gun. So those other ones are quick, they're easy. It's very obvious after you've run it that you've done the wrong thing. Now, the other option with Terraformer is to generate IAC by IDs. And this sounds like exactly what you're looking for, but it is very hard to do versus by tags, which is how we're actually going to do the IAC generation. So when you're doing it by ID, this is actually an extremely time-consuming way of going about generating IAC. First off, you have to go into the AWS console and you have to get a list of every single ARN and ID, every single resource that you want to generate code for. So if you're trying to do a Kubernetes cluster, you've got to go to EKS, you got to go to subnets to get some subnet stuff. You got to go to EC2 to get some node information. There's a lot of different stuff you got to piece together and find all of these IDs. So you have to kind of go on this like ID hunt, get them all cataloged someplace, and then you can come back and you can generate the IAC. So let's go ahead and I'm just going to reset this real quick. I will make a provider and then I will Terraform init this, and then we will look at the command to do this by ID. And so one of the first things you'll see when I paste the command here is it's not ARNs and it's not necessarily one-to-one. The way Terraformer works under the hood is it has a filtering system on those resources that we're passing in. So if we hop way back up here and you see resources all, or we hop to this other example where we say resources RDS, the way Terraformer works is it's hitting that cloud API for RDS. It's getting all of the resources, or it's going to try to get all of the resources. And if you put a filter on it, what it's going to do is it's going to filter down to very specific attribute and value matches. So if I say something like, oh, find all of the RDS with the ID OpenTofu or demo or webinar, what's going to do is it's going to find everything under RDS with that ID, the ID. So that might be my RDS cluster. It also might be a subnet group that has the same ID. Remember, IDs can conflict in AWS because the ARNs don't. And so it's very, very confusing when you first start seeing how the filtration system works in Terraformer because it's not one-to-one. So we can see here, I'm going to import RDS resources. I'm going to use a filter. I'm going to filter by the ID. Now you can filter by things like names and function names and lambdas. You can see here that I'm filtering by the value, and I actually have two values here. So they're colon delineated. So if you are filtering by ARNs, you need to take into account that like Terraformer is looking for the semicolon or the colon to be what delimits the values. So you have to kind of escape and quote things correctly when you use ARNs. But in this case, what you see is I'm searching for two values. I'm searching for this ID and I'm searching for this ID. And when we run this, what you'll see is it's actually going to get, I think, 3 resources. Yeah, there we go, 3 resources. So I only gave it 2 IDs, but I got 3 things. So why is that? Well, if we hop over here to by ID, let me close some of these other things really quick. You'll see that I've got an RDS cluster. I've got, and its ID is, there's this cluster identifier. I've got this subnet group, which has the same cluster ID or same identifier, its name, right? And then I have this DB instance, which has an identifier of this longer identifier here. So I gave it a filter. I said, hey, filter by ID. Now you notice that it knew that the name field is the ID of subnets, right? So like that's what makes this very confusing, is getting these filters right is very, very hard. I've used this tool for probably 2 or 3 years now. It took me about 30 minutes to get this filter right. And it's not even getting all 5 resources. So you can give this resources block here a comma separated list. So I can say RDS comma SG for security groups, and then I can add more filters on to filter specifically for security groups to get everything. But I'll leave that as an exercise for the reader. If you like just being punished, I would go ahead and try to write all the filters you want for this. But what we're going to do is I'm going to show you how I do it by tags, which I think is by far the easiest way. Now, I do want to point out a couple of things here with this approach. Again, you need to get all the identifiers first before you can do it by ID, and group everything together that you want to make into a single Terraform module. We did notice that, again, when we generated this did not make an RDS instance. It made a DB instance. So again, Terraformer does not support AWS RDS instances. So it picked one of these because under the hood, there's still a DB instance. So it's like, it kind of works, but we still need to correct this code here. And you can also see that it's got a number of conflicting attributes. If I actually do a tofu init, and then let's do a Terraform plan here. Oh, it's going to give me this error again. This is something I'll actually see pretty often from Terraformer. Is by default its state is Terraform 0.13 compatible. I think Terraform is version 1.8 now. So the way you can fix this is you can actually just replace the provider. This is right in the docs of Terraformer. It's such a common issue, but you can use this to kind of fix the provider there. So let's go ahead and do that plan. And what you'll see is there's a couple of these conflicting arguments. So Terraformer wasn't able to figure out what to do in this case of me using prefixes in my original IAC module. So I use prefixes. I let AWS generate the last half of this, so it created both. So in this scenario, I would have to delete that identifier for this code to work. So there's still stuff that you have to do, even though it's generating a much smaller set of resources. I'm only getting 3. The code's still not quite correct, and it still doesn't have a nice interface to it of variables and whatnot. Okie doke. So let's do it by tags. And this is the way that I recommend doing it. So the freaky thing you might be thinking about when you hear by tags is, I didn't put any tags on any of my resources. It's very common to not have tags, especially if you've been doing ClickOps. If you're a team that does ClickOps and you have a great tagging convention, wow. I don't know how you got there. I've met people like that. Like, we tag everything. It's like, oh, what do you use? Terraform? Like, nope, we just click in the console and copy and paste things from a spreadsheet. It's like, okay, that's great. But if you don't have IAC, my assumption is you don't have tags. You don't have good practices in place for managing your infrastructure. Why would you have a tagging convention? And so what I want to do is show you how I come up with a very quick tagging convention, use what I call a throwaway tagging convention to catalog my resources and then use that to generate ISE and then apply a real tagging convention so I can find resources in the future. So tagging your resources is by far, it's the easiest way to do Terraform code generation, by far. It's also the simplest filtering strategy. Remember, the only thing we have to work with in Terraformer is those filters. It's the simplest filtering strategy. And it's also the fastest, like wall clock time way to generate code. So this will actually run the fastest out of all of these approaches that we've done so far. There are tons of guides out there on the internet for best practices on how to do tagging strategies. AWS even has one of how they recommend you tag resources. That's all in the webinar GitHub repo. If you want a link to the AWS one, you can also just Google it. But what I'll say is, do not let the lack of tagging deter you. You can absolutely get started using this tagging approach with no tagging implementation or strategy in place. And with AWS, this is particularly easy. They have a bulk tagging tool. So you don't have to have 100% of your tagging strategy down. You just have to have enough tags in place to get the right resources to generate ISE. And then once you have this ISE, you're able to kind of come up with a broader tagging strategy that's now easy to apply to all of your resources. It's also important to remember that you don't have to get ISE right the first time, right? Like DevOps is all about iterations and building on the foundation that you have. This idea of Kaizen, continuous improvement, making things better, like let's get something that works and then make it work better, right? So what we want to do here is we want to get some resources under management in Terraform. And then from there, we can make them better modules, right? You're going to miss a resource. That's fine. You're going to miss something. You're going to miss an instance. You're going to miss a KMS key. You're going to miss a resource your first time around. Don't worry about getting everything. Just get started and then add to it as you go. You're not going to get the perfect module interface. If you're doing use case oriented modules, you have a much smaller interface. They're easier to fix, but it's okay if you don't get this right the first time. As long as you get something into IAC and then managed in an automated way, you've already taken a massive step to starting to streamline your DevOps and cloud operations. So the easiest way to get started is to define a tag for labeling all these resources that you want to pull into a single module. And again, I call this a throwaway tag. What we're going to do today is we're going to make a tag called module. That's going to be the key. And then the value is going to be AWS Aurora Postgres. So I'm going to look through all the resources that I have in my AWS account, which is over 600. I'm going to show you how I kind of find which resources are related. And then I apply a single tag to all those resources. And then I use that tag to generate IAC using Terraformer with a single, very, very simple filter. So what I want to do first is show you, there is a little bit of a cheat code that we have here. So I'm going to put this code here. This is using the AWS resource tagging API. And what I'm doing is I'm actually filtering for tags with the key webinar value OpenTofu. And then I'm running this through JQ to just print some values out. So we use the Terraform module to generate the resources that we're going to try to manage the resources that we're going to reverse generate Terraform for. I'm just kind of using the key that I put there to show you, like, these are the things that we want to get and generate IAC for. So there's about 5. I will say that this one right here is not one that we're looking for. This was from an earlier example that I did, and I apparently did not tear down that cluster. So I will tear that down right after this demo. But if you don't have any tags, which is probably where you are, then how do you get started? Well, what I want to do is show you the AWS resource tagging API. And there's APIs for bulk tagging and some of the other clouds as well. So I just ran this, and this is going to give me a list of literally every single one of my AWS resources. I got a ton of stuff in here. We got credits, so we're just burning them on AWS. But we got a ton of different resources in here. You can see a lot of our stuff already has a tagging strategy applied to it. What I'm going to go ahead and do is not be good at Vim commands. What I'm going to go ahead and do is I'm going to try to get just all of the ARNs out of my account, and I'm going to dump them to this single JSON file through JQ. And so this is all of the ARNs in my AWS account. And you can see that we have a lot. There's about 637 here, I think. Oh, the word count, that's not what I'm looking for. There's about 600 in here. Sorry, that's the full resources. Let me do this. Yeah, there's about 638. So so what I would normally do from here, if I was going into a brand new AWS account where, or sorry, not a brand new account, if I was joining a company and they had a bunch of resources that were already built and they did not have IAC, this would be one of the first things I would do is I'd run this to get an idea of everything that is running inside of this region. I'd actually take this list and I take it to the most useful tool of all times, Excel. And I'd paste this list literally into Excel. And then from there, what I would do is I would start to sequester off different resources into different worksheets that I think are grouped together. And what I do is I do that using hopefully naming conventions. So like this is the thing that sucks a little bit is like if you're joining a team where there's a bunch of resources that somebody's click ops, you don't know what conventions you even have in place. So you got to start to look at all these resources and figure out what are related. Now, I happen to have a good naming convention. So I can kind of take a cheat code here and just grep all these resources with the word OpenTofu, and I can see that I've got 4 of the resources. That's great. That's pretty close. Again, we're missing one. We know that there's 5, but this is close enough to get me started. Now, if you didn't have this cheat code, or if you didn't have like a really good, at least naming convention that you could grep on, I would literally copy this entire thing into a spreadsheet and then start breaking these resources out. Say, okay, I'm trying to create Terraform for my AWS cluster, RDS clusters. Well, I can see there's 2 of them right here. So I know that I've got 2 of them in my environment. There might be 3 in here. I don't know if this is actually sorted by resource. So I'd sort it in the spreadsheet and then say, okay, I've got 3 of these. Like I'd break these out to an RDS tab or worksheet in my spreadsheet. And then I would go through back to that main list and say, okay, well, what's related to this? Okay, I found some RDS instances and I kind of get all of my RDS stuff grouped together so I have an idea of what I have, and then break it down into trying to figure out the code for just one specific cluster. So I'd find this cluster, I'd find its instances, I'd find its subnet groups, etc. So again, like Terraformer and reverse IC generation is not a magic bullet. You still have to have a pretty good command of the cloud, a pretty good understanding of what you have in your AWS, GCP, and Azure accounts. And then if you have naming or tagging conventions, it's going to help you. But if you don't, it's really a hunt and peck scenario. You kind of got to group everything together. So I know what resources I want to apply these tags to. So if you went through the spreadsheet process, you get down to maybe a tab that just had these 4 things in it. If you're interested, by the way, in the actual spreadsheet process of how I do this, send me an email or hit me up on Twitter or LinkedIn afterwards, and I can share one of my spreadsheets of where I've done a breakdown on this from. But what we're going to do is just kind of use this shorthand. We know that everything's labeled with OpenTofu or named with OpenTofu, so we're just going to grab this. So the next thing we're going to do is we're going to devise a pretty basic tagging strategy. So what I'm going to do is I'm going to apply the tag module AWS Aurora Postgres to this. This is the module that I'm trying to build. I'm going to apply this to the 4 resources that I know I want to pull into this. So what I'll do is go ahead and clear that out. I'll clear my screen a little bit too. I do this every time. Copy and paste stuff, and I copy my comments too. So what I'm doing here is I am using the AWS Resources API. It has a tag resources function, and you can give it an ARN list of all of the resources that you want to have the same tags. And so you can see there's this big list of all the resources that came back from that grep or came from one of your Excel workbooks if you were cataloging all this. And then I'm saying apply the tag module AWS Aurora Postgres. So I run that. I can see that came back okay. What is it? Oh my gosh, never mind. I messed up. You can see nothing messed up. I'm the worst at Bash. I swear I'm an ops engineer. But you can see that there was no failures came back. And now if I go ahead and actually search this tagging API and I use module as the key and then the value of AWS Aurora Postgres, you'll see that I got about 5 resources. Again, this is a cluster that I went through this earlier with during the demo, or not during demo prep that I need to take out. So you can see that it applied these tags to all 4 of those resources that I wanted to hit. So we're doing pretty good. So now what we're going to do is we're going to go ahead and do the generation by tag. Let's see where I'm at. Okay. So you will need to, again, initialize a provider. I just have the basic AWS one here. I'm going to run Terraform init. And while that's running, I'm just going to check the comments really quick to see if there's any questions. Channel. Okay. Okay. No. Come back over here. Okay. So now what we'll see is, remember that filter expression earlier that was pretty complicated. Now what we see is the filter expression is literally just focusing on my tags. I want to find where the name of the filter is tags.module and the value is AWS Aurora Postgres. I'm going to dump it out. I'm actually going to dump it out in a folder called generated because we're going to get pretty good code out of this, and it's going to be scoped to the exact resources that we want. And so I'm going to dump it to this generated directory so we can take a look at it really quick. But then we're going to use a little AI tool to enhance the code a bit. So let's go ahead and run this. Okay, you see that it got 4 of these RDS resources. Said it didn't get any security groups though that time. Did we not catch the security group in the? Let's do this really quick. There we go. Grab the ARN for this one real quick. I'm just going to rerun that command with this additional ARN in there. I apparently missed one. Okay, let's do this really quick. Okay, this is tag. Did I spell this wrong? Yes, I don't know how to spell resources. Okay, cool. So let's remove this generated code and then run that generation again, and we should hopefully get the security group this time as well. Hey, there we go. Got a security group as well. That is fantastic. The marvel of computers. All right, so let's go ahead and take a gander at these tags. Look at the generated code. And we're going to open up the entire thing this time. Okay, so first off, so this has gotten all the resources that we want. So the first thing you'll notice is it generated a variables file for me, and it didn't create any variables. Terraformer does not help you design an interface. That is up to you. And we also notices that it has a remote state that it generates that points to a remote state that we don't have. So first thing I do is throw that file away. You can see here it got the security group, and like I mentioned earlier, the security group rule, it put it into an inner block. So there is a environment variable that you can set on Terraformer to tell it not to do this, and it would create a separate resource. But this is good enough for now. You can see it created these really poor names. It is what it is. You also notice that it's got this VPC ID in here, which is fine. We'll probably want to pull this from a remote or put a variable for passing this in. Looking at the cluster, we'll see there is only one RDS cluster. Yay! It got exactly the one that we're looking for. So that's fantastic. You will notice that it did tags and tags all and the weird Boolean thing again. So we will have to straighten this out. It also did something pretty funky. It set up a remote state. So you saw that remote state earlier. It set up a remote state to try to pull something from itself. This will not work. So this is just something goofy that it does sometimes. Sometimes it doesn't. I don't know why, but it's a little goofy. And you can see that it did the referencing of this DB subnet. It doesn't always do this. So we're lucky that it figured this one out. Sometimes it's not able to figure it out, and it will just put in the string for like the subnet group name. So that's something you have to watch for. Providers, it updated the provider to put the newest version of AWS. That's cool. Thanks. It generated a bunch of outputs. I didn't ask it to make these outputs. It just decided which fields it should do an output for. These are all the IDs of every single resource. But you also see that the names here are pretty brutal. So we'll need to fix those. It got the subnet group. This is great. And again, it got my RDS instance, but it thinks it's a DB instance type. So like this will actually run. This will actually apply. So we'll go ahead and do that now just to see that. Let's see what directory I'm in. Let me fix the state really quick. Again, the state file will be the wrong state file. It is cool that it does generate the state. Let me show this to everybody really quick while that's running. So it does generate the state. That's pretty awesome. Now you are going to have to do state surgery and workspace surgery here to kind of make this a module that can be invoked multiple times for each of your RDS clusters. I had 2 or 3 RDS clusters that I'm going to try to back this out to. Okay, so that is running. There we go. And now if I run a tofu plan, so again, even though that's the wrong resource, it is okay as far as AWS is concerned. So we should get a plan here. See, there's a couple of conflicting arguments around these prefixes. So that's not great. We got to come back in here and delete all these conflicting arguments. Again, the Terraform code is not perfect. Again, this is going to get you 60 to 80% of the way there. So just to recap, like the code looks pretty good. Like it got got the right resources using this like throwaway tagging strategy. It generated all the right resources, split them out. It's a little cumbersome. It could be better. This is for us to kind of start working on now. It didn't generate any of our random providers, again, because they're not stored in AWS. Got the wrong resource type for DB instance. And the variables TF that it generated is effectively useless. So where do you go from here? Well, there's actually this really cool tool called Mods, M-O-D-S. And this is by the Charm Bracelet team. If you aren't familiar with Charm Bracelet, they're a dev team that makes a ton of really cool Go tools, different CLIs. We use a lot of their tooling in the Massdriver CLI. But they released this tool recently called Mods that lets you just pipe in anything from your command line and send it out to one of a bunch of different AI services. So I've already got my environment set up to use OpenAI v4. And so I can essentially, you can kind of see down here with their example, LS vids, pipe it through mods, organize them and summarize them, yada, yada, yada. We're going to use this to try to fix some of this Terraform code and see what it comes out looking like. So the first thing I do here is I remove this variables file because it is absolutely useless. And so what I'm going to do is I'm going to go ahead and I'm going to cat everything together, get one big Terraform file here of everything, and I'm going to pipe this to mods. And so you can specify if you don't want to send your Terraform code and your state files to OpenAI, that's fine. You can use like a local AI. You can run something with, Olama. It has a bunch of different backends that it supports, but it defaults to OpenAI GPT-4, which is what I'm going to use. Now, I'm going to do something here that might look scary to every software developer in the world, but I'm going for it. Word wrap. Do we want 80 columns? Hell no. We want 1,000. So apologies in advance for 1,000 columns wide. Why am I doing this? Well, OpenAI doesn't necessarily, and mods doesn't necessarily know that this is Terraform code. And if we leave the line wrap at 80, it'll just break in the middle of strings for like things like subnet group IDs and whatnot. So I just make this as big as possible because I'm going to copy and paste it into VS Code, which is going to run Terraform lint and format, and it's going to fix it anyway. So I make the word wrap really, really long. That'll stop mods from breaking strings in half and essentially giving you invalid syntax back. And then what I'm going to do is I'm going to share my prompt with you. So this is a big prompt. And this is the prompt that I've been building on for a couple of weeks. It works pretty good. So what I'm telling it to do, don't change any code besides what I ask. That one's really important. It will constantly change code. And you have to, I've had to reiterate this a bunch of times in this prompt, but this is Gen AI, right? We're at the pinnacle of technology here. It's amazing. Do not omit any attributes under any circumstances. So what happens a lot was it will come back and it will just omit all of this, and then it'll do stuff like your config. It's like, okay, thanks. That's not helpful. Return the full Terraform code with the changes I've requested. I need the code back in a copy pastable format. So under no circumstances omit code unless what I ask to be removed. Remove tags all. If all tags are consistent across all resources, remove tags as well and move them to the default tags on the provider. So This is really nice if you have a consistent tagging scheme that you apply, and all of your resources that would have ended up in the same Terraform module would have the same tags. This is nice just to kind of clean up all of these tags and tags all that it generates, or this will remove them from all the module or all the resources, and then just do a single default tags on the AWS provider. I ask it to rename all resources to main if it has only one of that resource. If there are multiple resources, collapse them into a single resource with a for each block. So this is something we haven't seen, but let's say that my RDS cluster had 5 instances because we've auto scaled up. If you run Terraform, it'll actually make 5 different resource blocks for your instances, which gives you no ability to kind of have scale and parity at the same time. So if you have that module and you apply it to staging, you're going to have 5 instances in staging, 5 instances in prod, 5 instances in QA, 5 instances in your preview environment. It doesn't give you them as a for each, which makes it a little easier for you to pass in parameters to control how many of that resource is created. So I ask it to go ahead and do this as well. We actually won't see this part in this demo though, but this does work pretty well. It doesn't always nail it, but it gets pretty close. For any ID, name, or ARN attributes, reference what looks like the appropriate resource in the file instead of keeping the hard-coded ID, name, or ARN value. So you can see that it did this really goofy thing here with this Terraform remote state that doesn't exist. But a lot of times, if it can't exactly figure out what ARN it is, it will just hard code them. And so what I'm asking it to do is actually replace it with a reference like this. And you'll note that this has like the old style references too. I should probably add a prompt to clean that up. Never try to create references or remote state or data lookups. So this one's a little important prompt here. It will assume any ARN that it sees that it can't necessarily determine or in your code. It will try to generate data lookups for them, and they're pretty freaking wrong. So I just ask it to not do that. I usually avoid data lookups unless absolutely necessary. I'll usually try to pass in variables instead. So you feel free to remove that one if you like data lookups. Do not add any resources that aren't already in the file. Don't know why that's important, but it will occasionally just give you other random resources. Never word wrap long lines. Assume I have no local state file, but I do have a list of AWS resources that I need to import into this module. Give me the import commands as well. So what I'm expecting to come back here, if this works like it normally does, and sometimes I have to run this like 2 or 3 times to get what I want, this will dump a bunch of Terraform, and then it will dump the Terraform import commands to update the state file. So let's go ahead and run this. And it's going to start printing the code. Okay, so what you'll see there is it ignored me. It went ahead and added a cluster snapshot, which I don't believe we actually... Oh, no, we did actually pick up a cluster snapshot in this accidentally. No, we didn't. Generated by tags, cluster snapshot. We did. We did pick up one. Okay, we picked up one somehow. So we'll delete that. You can go and you see that it's still got this instance that we'll have to correct, but we'll actually run that so you can see that it'll actually work with that. So one of the other things, you can see that it fixed the name here, which is really nice. It gave it the name main. You can see that also gave it the name main there. These subnets are inputs, so I'm going to have to back those out to variables. See, they got the RDS cluster. It got the right. That's goofy. Cluster members. Oh, that's right. Got the reference there. Got the subnet group there. And it fixed the names of my outputs. Pretty cool. And now what it's going to do is it's going to give me some import commands down at the bottom to import. And so that does that sometimes because computers are fun. I can do mod-s, mods-s, with the last command. So what I'm going to do is I'm going to go ahead and copy all of this, copy this code. I'm going to come back over here to by tags. I'm going to make a new folder called AI. Okay, and something in here has invalid syntax still. Despite all those times of me telling it not to word wrap, it still decided to. I love artificial intelligence. It's extremely artificial. Okay, here's another one. Ooh, that's a fun little one to word wrap on. Okay. Okay. That looks a bit more formatted. So what I'm going to do is I'm going to go ahead and tofu init. Okie doke. See if we still got any more questions. Sorry for joining late. No problem. Okay, so that's been initialized. So now what I'm going to do is it gave me those it gave me those Terraform import commands at the end. I'm going to go ahead and run those with the IDs that I know to generate the state file. So again, when you run Terraformer, it does create a state file. But what I did was I just piped all the Terraform code into mods to generate new Terraform code. So I didn't send it my state file. You could also probably send it your state file and tell it to adjust the names there as well. But I find this to be a little bit easier. It means I don't have to go and look at like a 15,000 line file trying to make sure it got everything right. I just ask it to give me the import statements instead. So now I should be able to run a tofu plan. I might have a couple of code errors in here. Let's see what they are real quick. Name prefix on line 114. So let's go ahead and, I swear I know how to use a computer. I'm so zoomed in. I feel like I'm in a very, very weird environment. So I got name prefix and I got the name. So I'm just going to remove the name there. The reason why is I've got this name prefix. The actual name is in my state file. I don't need to worry about that one. And then that might have been it. I think that was the only error that I had, was that one naming conflict. Nope, there's one more. Line 41. Same thing. I got this prefix and this identifier. Remove that. Tofu plan. Invalid value. DB cluster snapshot identifier. I'm just going to go ahead and take this one out because I don't care about the snapshots anyway. AWS DB cluster snapshot. And it's just one that I accidentally tagged. Remember, we were only trying to get 4 resources since we have the ingress being put inside the block of that security rule. Cool. So you can see that now I have Terraform that is actually managing these resources that we started with. And I've been able to go back, get decent looking Terraform code. Now, to be clear, I still need to do workspace surgery and variable definitions for these modules. But I actually have real IAC that is now somewhat nice looking. It's all in one file. I need to break that up too. But you can see it's ready to manage these instances. And what's really wild is it's ready to manage this DB instance, even though we know that's a cluster instance. So let's go ahead and just mess some stuff up in tofu apply. Cool. And there it is. It changed it. Now, if we go back to my, tofu plan. Again, here, if we look at the instances, we'll see that it's an RDS cluster instance. But if we tofu plan, we should see, now this is me switching back to the original Terraform, right? I should see that changes were applied to this from the other one. So you can see that it did pick up some of the module and tag changes. I'm going to go ahead and apply these again. I know how to spell. Cool. And now I can use either one of these modules to tear down my resources at this point in time. So again, what we did is we looked at Terraformer. the different ways it has of generating IAC, and then kind of focus on this tagging strategy. And I think that honestly, there's a lot of filtering options available. This tagging strategy is probably the best and fastest way if you have a lot of resources to reverse generate code for. Generate code for. So again, if you have questions about how I do the spreadsheet, I kind of left it out because it's not really like the most exciting thing to watch. But if you are interested in how I do that and my process for taking all of those ARNs and starting to group them together and figure out what's related, happy to share how I do that. Maybe I'll even put together another webinar on that very uninteresting, boring part. But we've got some Terraform now that works. We got some more work to do, but I didn't have to write all these resources and manually copy. And this is probably, if you're wondering, like, what's the point of this if I still have to write Terraform? Well, it's very tedious to copy every single one of these values in. So like that is the nice part. So now I can start to look at these resources and think, okay, well, what do I want my developers to have access to change? Well, maybe I want to let them pick the retention period. That's great. Maybe I don't want to enable them to turn off encryption. Maybe I want encryption on all the time, and I'll hard code that encryption true. So hope this was informative. I hope it was helpful. Does this work for Terraform as well, or just OpenTofu? Yeah, no. So sorry, I just saw that question. This works for both. So Terraformer, just to be clear, only works with Terraform. It actually is looking for the provider files, which are the same, but it's looking for them under the Terraform path. And so I was doing Terraform init followed by tofu init today, and that was to get Terraformer to have the files it needs, and then I was tofu initting, and it all just works. The other way that you can do this is you can just symlink. So that's the way I normally do it. Is I have all of my provider directories for Terraform symlinked to my OpenTofu ones, and Terraformer still works. It just doesn't know to look under the OpenTofu directories. So yeah, it'll definitely work with either. Any other questions? Awesome. Well, we did share the GitHub repo, so that is available, and it should be copy and pastable. At the end, just make sure you do run Terraform destroy or tofu destroy to tear down the resources that are created. This will also be posted on YouTube shortly. So if you want to watch this again, just head over to our YouTube channel. We have a webinars playlist, and you should see it up here there. And it's also always on our webinars landing page on the massdriver.cloud website. If you are starting to embark on an IAC journey and need a great way of running your infrastructure as code, I'd suggest checking out MassDriver. You can go to massdriver.cloud, click the sign in button at the top, and you can register for a free account. You can do pretty much everything in the platform with our free account. And what it allows you to do is design modules in Terraform, Helm, Bicep, CloudFormation, publish them, and then allow your developers to essentially build stacks of resources by diagramming them. So they can just come in, they can diagram their infrastructure, and all the provisioning happens using your Terraform modules. So it's a really great way of delivering self-service to your engineering teams in a very lo-fi, no-code feeling way to them. But then it gives you everything you need as an operations person to be confident that engineers are deploying secure, compliant infrastructure, that they're following your guardrails, and then you end up with an audit trail of everything that they've done. So if you do need to hop in and figure out what's going on with something, it's very easy to figure it out. And you always have this context of your diagram. So essentially you're getting infrastructure as diagrams, which is pretty cool, all powered by your infrastructure as code. So awesome. Thanks for everybody for showing up. I really appreciate it. I appreciated you hanging the extra 8 minutes. I thought I was going to get this in under an hour, but I'm Corey O'Daniel on LinkedIn, Corey O'Daniel on Twitter, Corey O'Daniel on GitHub. Feel free to ping me on any of those social networks if you got any questions and any comments about the presentation, anything that I could have done better, would love to know. Thanks so much. Have a great day.